Hey everyone, today we will keep practicing with the notion of independence and with the conditioning trick. In particular, we will solve the problem of points, an important milestone in the early development of probability theory. But we will start with a simpler problem. Exercise 1. Two players take turns flipping a coin. Suppose that the first player to obtain a head wins this game. It should be clear that the player who starts the game has an advantage. Let's find out how much of an advantage he or she has. Let's compute the probability that the player who starts wins. For instance, if player who starts, player 1, flips a tail, then player 2 flips a coin again, and suppose she has a tail, then it goes back to player 1 and he flips a tail, and then player 2 flips a coin and suppose he has a head, the game ends and the winner is player 2. It would be hard to try and compute this probability directly because there are infinitely many possible scenarios. But the conditioning trick helps here. Specifically, let's condition on the outcome of the first flip. The probability of E, the event that the player who starts wins, can be then computed using the law of total probability. Probability that this event happens given that the first flip is a head, times probability that the first flip is a head, plus the conditional probability of our event given that the first flip is a tail, times the probability that the first flip is a tail. Now let's compute all these four terms. The probability of getting a head is 1/2, and so is probability of getting the tail. What's this conditional probability? Here we assume that player 1 flips a head. In that case, by the rules of the game, player 1 automatically wins. So E, the event of interest, always happens. And so that conditional probability equals 1. Next, what happens if player 1 flips a tail? Like this. In that case, the game resets and player 2 starts the game now. Like this. We still want to compute the probability that player 1 wins, which means player 2 loses. So here is the probability that with this new game, when player 2 starts, that player loses. In other words, this is a probability that the player who starts loses. And that is just a complement to the probability of E, the player who starts wins. So we obtained this equality. P of E equals 1 times 1/2 plus 1 minus P of E times 1/2. It's funny that we wanted to compute P of E, and we computed this in terms of P of E itself. So we didn't quite get the answer. However, we get an equality. We can solve this equality for P of E and get P of E equals 2/3. Do it. And that's the answer to our problem. As we predicted, the player who starts has an advantage. And so the probability of him or her winning is larger than 1/2, and it happens to be 2/3. And now we are ready for the problem of points, which is historically one of the first problems in probability theory. Teams A and B play against each other continually. The team that wins a total of 5 games wins the tournament. By the way, what's the maximum number of games that can be played in this tournament? It's 9. 4 plus 5. Now, assume team A is a little stronger than team B. Specifically, let's assume that team A has probability 0.6 to win any given game, independently of the other games. let's compute the probability that team A wins the tournament. Team A is slightly stronger, so this probability should be bigger than 1/2. Let's find out the exact value. By the rules of this game, Team A wins the tournament if, and only if, Team A wins 5 games before B does. Let's denote this event by E55. Subscript 55 is a reminder that A needs to win 5 games before B wins 5 games. To solve this problem, we will use the conditioning trick again. And like in the previous example, we will condition on the outcome of the first game. Using the law of total probability, we can then compute the probability of E55 as the conditional probability, given that Team A wins the first game, which we denote by A1, plus the conditional probability given that Team B wins the first game, which we denote by B1. Now let's compute all the 4 terms here. Since A has probability 0.6 to win any given game, this probability that A wins the first game is 0.6, and the probability that B wins that game is the complement of it, 0.4. Next, let's compute this term. If we assume that Team A has won the first game, then in order to win the tournament, it needs to win just 4 more games before B wins 5. So that probability is the same as P of E45, the probability that A wins 4 games before B wins 5. What is this probability? Here we assume that Team B wins the first game. If Team B won the first game, then in order to win the tournament, A needs still to win 5 games before B wins 4 more. So this probability can be written as E54, the probability that A wins 5 games before B wins 4. We get an equation, P of E55 equals 0.6 times this plus 0.4 times this. That's not very satisfying. We hope to have a specific number here and we get an equality. In fact, we don't have just one equality. For any pair of numbers, instead of 5, 5, we can argue similarly. If we introduce a variable P and M, which is the probability of the event Pn, M, the probability that Team A wins the total of n games before Team B wins M, we can argue similarly here, and we get Pnm equals 0.6 Pn minus 1m plus 0.4 Pnm minus 1. Do it. Argue exactly as we did before. These equalities are valid for any n and m. What else do we know? We also know Pn0. This is the probability that Team A wins n games before Team B wins 0 games. How can that happen? In the very beginning of the tournament, the count is 0-0. So it will never happen that A can win any games before B wins 0. So that probability is 0. And what's the probability of 0m? That is the probability that A wins no games before B wins m. Well, in the very beginning, again, the count is 0-0. So this event happened immediately. A immediately has won 0 games, even before playing anything. So that probability is 1. And here we have a system of linear equations in these variables, P and M. We can put it in the computer and it will solve for us. Alternatively, we can use the structure of the system and solve it manually. Indeed, the indices nm get reduced to n-1 and m-1 at this step. So now we iterate and reduce the indices even more and more and more until we get to n0 and 0m. That is an alternative direct way of solving this equation. Try to do it. Either way, whether you solve it on a computer or you solve it by iteration, you will get P55 is 0.73. So team A wins with probability 73%. As we predicted, it's a little above 50%. We solved a particular instance of the problem of points. You may want to read about this fascinating problem a little bit more. Thank you, and stay with me for the next episode.